Hi, welcome to my channel. In the previous video, we discussed about MNST dataset, and based on this MNST dataset, we are going to find out the training the binary classifier, training binary classifier. That means our model is a binary class classification. That is, the given image is 5 or not 5. It is simply called as a binary classifiers. So, and then after the training of the binary classifier, we are going to find out the performance of the model. Okay, so that is measuring accuracy using cross validation. And then we are finding the different types of and also apply the different types of performance metrics based on the confusion matrix. So here based on confusion matrix, we are finding the precision, recall, F1 score, and also we find out the precision recall trade-off, and also we find out the AUC, ROC, AUC curve for the binary class classification. Later we discussed about the multi-class classification, multi-class classification. That means we are going to assign the multiple classes at a time. Okay, and then we are going to find out the error analysis. So like that we have discussed about the different topics in the previous class. Please watch those videos. Now in this video we are going to see the what is meaning of multi-label classification. Okay, so in the until now we are going to see the each instance has always been assigned to just one class only. For example, in the given data set there is some features are there. Based on the features we are going to assign only one class label, that is a 5. Okay, now so based on features we are going to assign a class label as a 1. Like that we are going to assign the class label. So simply that is called as a one class classification. Okay, we are assigning some class label. In some cases you may want to your classifier to output the multiple classes for the given instance. Sometimes you have to give the multiple class labels for the given same instance. So consider face recognition example, that is a face recognition classifier. What should be if it recognizes the several people in the same picture? At that time we are going to assign the multi-label classification. So you should attach one tag for the one person it recognizes. Okay, so now for example the classifier has trained on a recognize the 3 faces like Alice, Bob and Charlie. Okay, now then the classifier shows in a picture. Suppose the classifier image contains person A is a Alice, Bob B, okay, Bob B and Bob Charlie. See, the 3 persons are in the image. Suppose you have then our classifier shows the picture. If the picture contains Alice and Charlie only A and B is there. Suppose our image contains only person A, Alice, and person B only, person C only. That is A and C only. At that time, our model gives the output in the form of a 101. That means the output contains the class label contains 101. That means Alice is yes, Bob is no. That means Bob is not present in the image and Charlie present in the image. So 101. 1 means yes, 0 means no. Is not present. 0 means the person is not present in the image. 1 means the Alice is present in the corresponding image. So like that we are going to classify. Simply this is called a multi-class classification. Multi-label classification. Such a classification system that outputs the multiple binary tags. Multiple binary tags is called as a multi-label classification system. That means for the same image, we are going to give the multiple labels for the different persons in the image. Simply that is called as a multi-level classification system. So if you want to go face recognition system, okay, but look at the some simple examples like from the sklearn dot neighbors import the k neighbors classifier. So here y underscore train, this is one class label that is called as a y underscore train underscore large equal to the actual train y underscore train underscore greater than equal to 7. That is one class. If the elements are greater than 7, that is assigned to one class label. Okay, and also we are giving the other class label is a y underscore train underscore odd equal to y underscore train mod of 2 equal to double equal to 1. That means if it is a the division by 1, okay, output equal to 1, then that becomes a odd number. Okay, so here greater than equal to 7, the given number is greater than equal to 7 or not, and the given number is odd or not, like that we are giving the two class labels for the given input. So y underscore multi-label equal to np dot c. Okay, we are going to give the all the class labels. So okay, for our model y underscore train underscore large, that is a more than greater than equal to 7, and this is the y underscore train underscore odd, that is a odd number. Then knn classifier, we are going to train the model is equal to k neighbors classifier. Okay, then we are going to train the model, our classifier model, okay, based on the fit function. For the fit function, provide the y x underscore train, and the corresponding class labels are y underscore multi-label. That multi-label contains two class labels. One is greater than equal to 7 and odd number. The given number is odd or not. Okay. Now this code creates a y underscore multi-label array containing the two target labels for the each digit. Now for example, the first indicates that whether or not the digit is large. That means the large means 7 or equal to greater than equal to 7. That is the output in the form of 7, 8 and 9. If it is true, it gets the output as a 1. Otherwise, it gets the output as a 0. The second indicates whether or not it is a odd number. If it is a odd, then we get the output as a yes. Otherwise, no. So the k neighbors classified instantly which support the multi-label classification, and we train it using the multiple target array. So now you can make a prediction and notice that it outputs the two labels. Okay, two labels. For example, knn underscore classification dot predictor based on some given input image. For example, input image is 5. For this, we are going to use the two things. So what are two things? One is greater than equal to 5, 7 or not, and whether given number is yes odd or not. If it is here the given digit number is 5 is less than is not greater than equal to 7, so that means you are getting output as a false, and the given input image 5 is a odd number. Okay, so then it is a true. So like that we are going to get the for the same input value, we are going to get the two labels for the same input value. Okay, simply this is called as a multi-label classification. So the digit 5 is indeed not large, that is a false value, and it is a odd value, thus it is a true value. Now there are many ways to evaluate the multi-label classifier, and selecting the right metric really depends on your project. Okay. Next, one approach is to measure the F1 score for each individual label. Then simply compute the average score. Then based on that one, we are going to find out the F1 score for all the labels. So for example here, y underscore train underscore knn underscore predict value equal to cross underscore val underscore predict of knn classifier y x underscore train value, or output variable label equal to y underscore multi label, and cross validation equal to 3. Then F1 score of okay multi label, that is your actual label value, actual values y underscore multi label, okay, comma your predicted model output value y underscore train underscore knn underscore predict value, average is equal to macro. Now, so we are getting the output as 0.9764. Okay, that means that all the labels are equally important. However, may not be the same case. Okay, so in particularly, if you have many more pictures of the Alice or than Bob or Charlie, you may want to get the more weight to the classifier scores of the picture of Alice. Okay, one simple option is to give the each label a weight equal to its support value. So that is the number of instances with the target label. So to do this simply set the average equal to weighted in the preceding code. Average equal to preceding score. So based on that, we are going to give the weightage of each and every class label. So in this way, we are going to find out the multi-label classification. Multi-label classification. In the next video, we are going to see the multi-output classification. Thank you. Thank you for watching our video. Please subscribe my channel. Thank you.